say that the current I in an electric conductor varies inversely with the resistance R of the conductor. The current is 1/2 ampere when the resistance is 336 ohms. What is the current when the resistance is 756 ohms? Okay, so if something varies inversely with something else, then that means that their product must be a constant. So in other words, I times R must be equal to some constant K. So in this particular problem, we're told that the current of 1/2 ampere is varying inversely with the resistance of 336 ohms. So that means that 1/2 multiplied by 336 is one particular constant. On the other hand, we're told that the resistance being at 756 ohms is asking for a certain resistance that we don't know. Right? Oh, sorry, that's the resistance. We're looking for the current. So the current is right there. So in other words, the current is an unknown, so that's going to be a variable. We'll put an X right here. But we are given that the ohms are 756, so we'll put 756 right here. Now notice that 1/2 times 336 is 168. So you get 168 equals X times 756. And then if we divide both sides by 756, what do we get? X equals 168 divided by 756, which is 2/9. So the answer to this problem would be 2/9 of an ampere. Okay, why don't you pause the video and try to do the problem again. Do it with these numbers though. The current I in an electric conductor varies inversely with the resistance R of the conductor. The current is 1/5 of an ampere when the resistance is 400 ohms. What is the current when the resistance is 800 ohms? So similar to last time, we're going to set up a relationship that does the current times the resistance. And on one hand, we're given a current of 1/5 of an ampere versus a resistance of 400. And on the other hand, we're given a what is the current, so an unknown, versus a particular resistance of 800. So now if we do the algebra that's involved, 1/5 of 400 would be 80. So 80 is equal to 800x. And then if we divide both sides by 800, we can now see that 1/10 is equal to the current in amperes. So the answer to this problem is 1/10.